A rational expression is in simplest form if its numerator and denominator have no common factors other than plus or minus 1. To simplify a rational expression, you apply the following property. Let A, B, and C be expressions with B not equal to 0 and C not equal to 0. Then the following property applies. If you have A times C divided by B times C, that fraction would simplify to A over B, because C divided by C is 1, and so the C's divide out. For example, we use this when simplifying fractions. If we had 15 over 65, 15 is 3 times 5, 65 is 13 times 5, so the 5's divide out to equal 1, and so you have 3 over 13 times 1, which is just 3 over 13. We can do the exact same idea with binomials rather than monomial factors. So if we had 4 times x plus 3 divided by the quantity x minus 5 times x plus 3, the x plus 3's would divide out. We'd be left with 4 over x minus 5. Please note, it is extremely important that you understand that you can only divide out common factors. And remember, factor means you're multiplying. You may not, I repeat, you may not divide out common terms. So terms are things that you add or subtract. So like x and 6 are terms. Factors would be if you had 3 times x plus 6, 3, and x plus 6 are factors. For example, if you had x times x plus 4 being divided by x, the top is in factored form. You have something times something else. So division is the opposite of multiplication. Therefore, you can divide out the x's and be left with the x plus 4. However, if you had 2x plus 5 divided by 2x, you cannot divide out the 2x because you have 2x plus 5 on the top, and division doesn't undo this addition sign, only subtraction would do that. You can't separate the 2x from the plus 5. Plus and minus signs, think of them like super glue. If they keep their terms together, you'd have to divide out the entire 2x plus 5. So this is not true. You should not do this under any circumstances. Let's take a look at how to go about simplifying some of these. So first of all, in order to be able to divide anything out, we need to have factors, meaning you need to factor. That is step 1. So we're going to take the numerator and factor it. It's a trinomial. I check for a greatest common factor, but x squared, negative 2x, and negative 15, they don't all have x's, and the largest number they're all divisible by is 1. So we don't have to factor out a GCF. We go straight to reverse FOIL. I know for my first terms I would need x times x in order to get the x squared. So now I'm thinking about what would multiply to negative 15, but add to the negative 2x. Well, we know that negative 5 times positive 3 equals negative 15. And negative 5 times x would give us negative 5x. X times 3 would give us positive 3x. So negative 5x plus 3x is negative 2x, exactly what we want. In the denominator, you have 2 terms, so we think about our strategies for 2 terms. We have GCF, but x squared and negative 9 are not divisible by anything other than 1, so we don't do GCF. And then it's either a difference of squares or sum or difference of cubes. Well, this isn't a cube, it's a square, it's x squared, and 9 is 3 squared. So we factor it with the difference of squares pattern. X times x is x squared, 3 times negative 3 is negative 9. So we've now completely factored the numerator and denominator. So we look for common factors that would divide out to equal 1. We have x plus 3 being divided by x plus 3. So that's a common factor. So you divide out the entire x plus 3 with the entire x plus 3 in the bottom. In the numerator, you're left with x minus 5. In the denominator, you're left with x minus 3. You cannot go any further because you don't have any more factors in common. So this is your final answer. Because remember, you cannot separate the x from the minus 5 via division. The only way to undo this would be to add. Same thing down here, you cannot separate the x from the minus 3. So we can't simplify these, and x minus 5 is not the same as x minus 3. So that's all you can do. Number 2, same process. We're going to completely factor. We have a trinomial in the numerator, so we're thinking reverse FOIL. They don't all have x's, and the largest number they're all divisible by is 1. So we don't need to take out a GCF. I know that I need x times x to get x squared. To multiply to positive 16 but add to negative 8x, I would need negative 4 and negative 4. So that x times x is x squared. Negative 4x and negative 4x gives us negative 8x. And negative 4 times negative 4 is positive 16. In the denominator, again, we have a trinomial. We check for a greatest common factor, but they don't all have an x. And the largest number they're all 3 divisible by is 1 because of the 1x squared. So we skip GCF, move on to reverse FOIL. We know that x times x gives us x squared. So we're thinking what two numbers would multiply to negative 24 but add to 2? We want positive 6 and negative 4. So that x times x gives us the x squared. The outsides gives you negative 4x. The inside's positive 6x, and 6x take away 4x gives you the 2x. 6 times negative 4 gives you the negative 24. So now we have a common factor. We have x minus 4 being divided by x minus 4. So those divide out to equal 1, and you're left with the x minus 4 over x plus 6. And again, that's as far as we can go because we don't have any more common factors. So number 3, this time we have monomials, and we're going to take a look at how to multiply with them. So to multiply, you have some options. You could multiply straight across the top, straight across the bottom, and then simplify. Or you can start by simplifying top to bottom and then multiply. I always recommend simplifying as much as possible before you do anything else so that you're working with smaller values. So 8 divided by 2 gives us 4. We have an x cubed being divided by an x to the first. So we're going to get x squared. And then we have a y over a y squared. Well, the extra y would be in the bottom. Because you have 2 y's in the bottom and only 1 in the top. If you subtract their exponents, you do the 1, take away 2, which is negative 1, so that tells you to drop it to the denominator. So the second fraction, 7 doesn't divide evenly by 4. We have x to the 4th. And then we have y cubed over y to the first, which would leave us with y squared. So now you still have options. We could multiply straight across and then reduce. You could also do some cross-reducing here as well. You could see that 4 is being divided by 4, so that could divide out, and you could simplify your y's. I'm going to show it with multiplying straight across. So I'm going to take 4 times 7. And I'll get 28. X squared times x to the 4th gives me x to the 6th. Then we have y squared all over 4y. Alright, well 28 divided by 4 gives us 7. We have x to the 6th. And then a y squared divided by y to the 1st is just y to the 1st. So we get 7x to the 6th times y. Same idea on the next one. So we have 5 and 5/3. X squared divided by x would leave us with an x. Y cubed divided by y to the 4th would give us y to the negative 1st, or the y goes on the bottom. There are more y's down below than on the top. 27 and 15 are both divisible by 3, so I'm going to reduce that to 9/5. X to the 5th divided by x to the 4th gives you x, and then we have an extra y on the bottom. So now if we multiply straight across, 5 times 9 is 45, x times x is x squared. Three times 5 is 15, y times y is y squared. 45 is divisible by 15, you get 3. So it's 3x squared divided by y squared. In number 5, we get back to our polynomials. We've got some binomials, trinomials, and one monomial. Your first step is to factor anything that's not a monomial. So if we start here, I notice a GCF right away. They're both divisible by 3x. And I notice that the highest degree variable has a negative leading coefficient, so I'm actually going to factor out a negative 3x so that we can get that term with the highest degree to have a positive exponent. So if we take out a negative 3x, we'd have negative 1 plus x, because 3x divided by negative 3x leaves you with negative 1. Negative 3x squared divided by negative 3x leaves you with positive x. In the denominator, I need to reverse FOIL since it's a trinomial. X squared, 4x, and negative 5, they don't all have x's, and the largest number they're all divisible by is 1 because of the x squared. So you know you need x times x to get x squared. A positive 5 and a negative 1 will multiply to negative 5, but will allow us to get positive 4x from the outsides and insides, because we'd have 5x from the insides, negative 1x for the outsides. So 5x plus negative 1x gives you the 4x. Same thing with your second fraction. So x squared plus x minus 20, we need x times x. Negative 20 is our product, but 1 is the sum, so we want positive 5, negative 4, and then we've got 3x. Well, I'm going to rewrite this first one just a little. Negative 1 plus x is the same as x minus 1. Just so I can see a little better my common factors. And so we've got x minus 1 being divided by x minus 1, so that's going to divide out. So then I've got, in the top, if I multiply, I've got negative 3x times x plus 5 times x minus 4. In the denominator, I've got 3x times x plus 5. So x plus 5 divided by x plus 5 gives us 1. Negative 3x divided by 3x gives us negative 1. So you have negative 1 times x minus 4. So you could leave it like that, or you could say negative x plus 4. Either is fine. Okay, so number 6. I'm looking at the numerator of the first fraction. Again, I see a greatest common factor right away. 20x and negative 5x squared are both divisible by 5x. So we factor out a 5x. 5x times 4 would get us 20x. And you know what? Let's take out a negative 5x because I'm realizing that my highest degree variable has the negative exponent. We like it to have a positive. It has a negative leading coefficient. We like its coefficient to be positive so it can sit out front as a positive. So if I take out negative 5x instead, 20x divided by negative 5x will give me negative 4. Negative 5x squared divided by negative 5x will give us positive x. In the denominator, x squared minus x, they're both divisible by x. So if I factor out an x, I'd have x times x minus 1. Got to reverse FOIL the numerator of the second fraction. The GCF is 1 since all terms don't have an x, and there's 1x squared, which means the largest number. They're all divisible by is 1. So with reverse FOIL, we know we need x times x to get x squared. And we need positive 4 and negative 1, so that the outsides and insides give us 4x take away 1x, which is 3x. X squared minus 16. Difference of squares, so you want x plus 4, x minus 4, so that you get the x squared. Negative 4x plus 4x is 0x, so the middle drops out. Positive 4 times negative 4 gives you the negative 16. So now again, I'm going to rewrite this numerator of the first one a bit. Instead of negative 4 plus x, I'm going to write it as x minus 4. And then I've got some simplifying I can do in both fractions. So in the second fraction, you see x plus 4 being divided by x plus 4, so those divide out. In the first fraction, you have x being divided by x, so that divides out. So if we multiply the tops, we've got negative 5 times the x minus 4 times x minus 1. In the denominator, you're left with x minus 1 times x minus 4. So then, x minus 4 divided by x minus 4 is 1. X minus 1 divided by x minus 1 is 1. So negative 5 times 1 gives us negative 5. So division, remember we never divide by a fraction. Instead we multiply by its reciprocal. So we can rewrite this problem as a product. We're going to multiply by x squared minus 2x plus 4 over 1. So you take the reciprocal of the thing you're dividing by. Remember, reciprocal means top numerator becomes denominator, denominator becomes numerator. And now I've got a factor. So on my first fraction, x minus 4 is as factored as it can be. In the bottom, you've got the sum of cubes. So you know that a is x, b is 2. So you'll get x plus 2 times x squared minus 2x plus 4. And we're multiplying that by x squared minus 2x plus 4. So we can see if we multiply the numerators, x minus 4 times x squared minus 2x plus 4 over x plus 2 times x squared minus 2x plus 4. This trinomial, which can't be factored any further, is going to divide out between the numerator and the denominator. And we're left with x minus 4 over x plus 2. So division problems are the same as multiplication, you just need one additional step at the beginning. Change it from division into multiplication by taking the reciprocal of the second fraction. So in number 8, 4x divided by 5x minus 20 times x squared minus 6x plus 8 over x squared minus 2x. So right away I see GCF. So we've got 4x over 5 times x minus 4. Reverse FOIL to add to 8, but to multiply to 8 but add to negative 6. X minus 4, x minus 2. And in the denominator, I see a GCF. X squared and negative 2x are both divisible by x. So you factor out the x times x gives you x squared, and x times negative 2 gives you the negative 2x. And so we see x minus 2 being divided by x minus 2. And if we multiply straight across the numerators, we've got 4x times x minus 4 over 5 times x minus 4. So x minus 4 divided by x minus 4 is 1. X divided by x is 1. So the final answer to this problem is 4/5. So when we're simplifying rational expressions, remember step 1 is to factor. With factoring, always check for a greatest common factor first, then count your number of terms and think about your strategies. Once it's factored, if you're asked to multiply, then you just multiply straight across the numerators. And we don't actually mean to multiply anything out. We just mean, sit them all next to each other in the numerator so that multiplication is implied. Just kind of shove them next to one another in the numerator and the denominator. Then once they're shoved all together in one fraction, like this, then look for values of 1. Anything being divided by itself. So the x divided by the x minus 4 divided by x minus 4. If you have division, just one additional step. Change it to multiplication and take the reciprocal of the divisor, the thing you're dividing by.